Okay, so the test coming up on Monday is going to have a variety of problems, and so one of the problems will be this incline, well, this plate that's submerged, and so this particular drawing, there's a plate here, there's a plate here, and there's a plate here. They're all connected. So uh, my thinking is to treat these separately. So you have one plate here, you have one plate here, and you have one plate here. So let's go ahead and close this. Let's look at another page. And so this is directly from Shelby here. And you'll see that we have an origin here. We have A here. So we're going to consider all of these things. We have our length here. We have our length here. We have our length here. So the way in which I'm thinking we should analyze this problem is by considering L on this vertically submerged plate first, and then this particular submerged plate second, and then this submerged plate third. Now what we're going to be looking for is this T. We want to find the amount of force that we have to apply at this point to keep this plate from moving. And this should be our pivot point right here. This is our H here, and this is our A here. So from this point up here. So I don't know fully what this means right here. So just going back over that a little bit, this is going to be the first plate that we're going to consider, and we need a few equations. One of the equations that we're going to need is this one, and it's a force, the resultant force on this plate, which is going to act something like this. It's going to act on this plate here, is equal to gamma of the fluid times HC, and that's to the center of the plate. So we're going to measure that from this location down to the center of this plate. So this should be our HC. And then we're going to have the area of the plate. Okay, so if we just continue on here, to the center of the plate is going to be, and we can go into all of that. I think I just wanted to, it basically says HC is the vertical distance from the free surface, and here's our free surface right here, to the centroid of area. So the centroid of the area is going to be somewhere in here. So basically we take our centroid. So since this angle here is 30 degrees, we can actually get this centroid by just using our sine, cosine, and tangent functions. So we know that the only thing that we want to have is this location. So, or the, how can I say, oh, we're going to want to know what the hypotenuse is, and we're going to take half of that. So this side here is going to be, oh boy, I think I'm thinking about this wrong, but that's okay. Wow, because this is L, the hypotenuse is L. So let's take sine of the angle theta equals to the opposite side, which is the side that I'm pointing to, over the hypotenuse. So let's just say that the opposite side is, and I don't know what to call that. Let's call that HC divided by, so HC is, ooh, I see. Okay, so HC is not quite that. It's actually HC plus, so HC over L. Because L is a hypotenuse. But HC is measured from this location, which in my mind that poses that's a problem, because we're not starting here for HC. We actually have this other piece from this location down to this location. And that's going to be our A. A actually, it's not down here. So let me go ahead and erase that. It's not down here. It's actually right here. Okay? So we have to include that portion as well if we're going to measure HC. That's why it's important. So we have HC equals to A plus, okay, and if we want this, and I'm saying HC, but let's just say HC, this one is, let's call it HC prime. And HC equals to H is equal to A plus H sub C prime, where H sub C prime is just going to be L, and I'm going to say 1/2 H sub C prime. It's just going to be L sine of theta, and we know that theta is 30. So if we substitute that back into that equation for H sub C, we end up with A plus L over 2 sine of theta. So that's going to be our HC. Our fluid is water. So we're going to know what the specific weight is for that. That's 9,800 Newton meters cubed. And then we also know the area of the plate, because the plate is just the length times the width, and the width is 1 meter. Okay, the next video is going to be, well, I guess I can continue on. If we continue on and look at this particular plate, now that we've analyzed that portion, and it's something that I wanted to do even more than that. I wanted to actually bring in the moments, but at this point, just to analyze the forces would be good. So now we have a force that's going to act pretty much at the center of this plate. All right, and I'm going to call that our resultant force. This is just another one. I won't call it resultant force 2, 3, and 4. I want to just treat them separately right now. And maybe later on we'll come back to it and relabel them. But we have F of R is equal to, and this is one thing I had to look for, and for whatever reason, I cannot necessarily remember it right offhand. So let me see if I can go back and find this. I think if we use the same thing, if we say gamma of the fluid times H, and I want to say HC, but let's just say H, times the area, we know that gamma times H is pressure, and we know that area of the plate is the area of the plate. And so the area of the plate is going to be the same as the last one, but H is now, it's now all the way down. So this is now going to be considered our H, and I'm not using HC, but I am going to, because it should be down to the centroid of the area as well. Even though I think we think about it a little bit differently, but still, it's going to be in the center of the plate. So this, we know that gamma of the fluid is just H2O, 9,800 Newton meters cubed. And then we have H, and I better put HC here. HC is now just going to be A, okay? And again, I change this to here. So this is going to be A plus L sine theta, because we're only concerned with the horizontal component here. And this is our L sine theta. All right. And so now we have those two pieces, and the area of the plate, again, is L times omega. So we should be able to substitute the appropriate things in there. Okay, so basically we would add these forces up, and at some point we're going to find our lengths from this pivot point. Okay, so let's just continue on and let's look at the next one. So in this particular case, again, we are going to have something very similar. F sub r equals to gamma, and I'll just put in H2O. Well, how about of the fluid? Of the fluid, no matter what it is, times HC times the area of the plate. Okay, so now the area, or HC, is going to be located here. So we know that gamma of the fluid is just gamma H2O. And now we know HC, which is going to be here. It's going to come all the way down to this point. HC is equal to A plus L sine theta, based on the same thing that we did before. So here's our L sine theta. And here's our A, L sine theta. And then half of L. So now plus L over 2. So if I were to write this up here, this is just going to be A plus L sine theta plus L over 2. Cool? And so we have all of that information. We can put that back in, and now we know the forces from the fluid acting on each one of these plates. That's pretty much what we're saying.